Good evening, good morning, everyone, and welcome to Sky Observers Hangout live from the campus of Southern Illinois University in Carbondale, Illinois. We are so delighted to have you. My name is Michelle, and I'm the Director of Public Observing at the Adler Planetarium in Chicago.
And I'm Hunter, Public Observing Educator at the Adler Planetarium, and we are so excited to have you all here today for this very special Lunar Eclipse episode of Sky Observers Hangout. Now, it's not just the two of us putting on this show tonight. We've got lots of help behind the scenes, so we want to give all of them a shout out today as well. If you're joining us online, well, I guess all of you are joining us online, we'll have a couple of folks in the chat helping out. If you see the Adler Planetarium name, that's Colleen. She will be taking a look at all of your messages tonight, sending us along any questions that you have, so make sure to post your thoughts throughout the evening tonight. We'll also have Geza in the chat, Star Geza, our astronomer friend, who will be answering all those extra hard-hitting astronomy questions that you have. And then we've got tons of folks here helping us out in person, our producers Dylan and Brody behind the cameras, and then a bunch of wonderful telescope operators headed by Richard here, and some other wonderful guests that we'll be having here live on the show later tonight. So an exciting night ahead of us.
It is. We're going to be with you for at least about an hour and a half, so settle in, everyone. This is going to be a lot of fun. And we also want to give a special hello to our friends at the Farmer's Almanac and all those joining us through farmersalmanac.com. Now, if this is your first time here, welcome. So Sky Observers Hangout is our chance to gather together to nerd out about the sky. If this is something you just want to sit back and watch, that is just totally fine. If you want to participate with us, hey, head to the chat and send us a comment, send us a question. Let us know, where are you tuning in from? And so Colleen is going to put stuff in the chat from time to time. Feel free to interact with us and with each other. This show is totally live, and so we love to know your questions. Now,
and if you enjoy the content tonight and want to see more of it, you can also hit subscribe right down below. Subscribe to the Adler Planetarium's YouTube channel, where we not only do these Sky Observers Hangout live streams, where we provide live telescope views right alongside with you, but also tons of other wonderful astronomy content. So definitely worth checking out if this is something that you're interested in. We'd love to see you in the future.
Exactly. So let's see, where are we coming in
and we've already
from?
started to get some things coming in. I see Georgia, Charlie, and Paloma coming from Rochester, Minnesota.
Exactly.
And even some other questions already starting to come in.
Oh,
I was looking in the chat earlier. We've got folks coming from Missouri, Oregon. I saw some Chicago shout outs. Some friends down here in Carbondale, Cicero and Aurora, folks from all over Illinois tonight. So it is so wonderful to see people joining from all over. And you know what's great about this lunar eclipse tonight is, you know, anybody in North or South America is going to get the chance to see this lunar eclipse. So we will, hopefully you can watch right alongside us tonight.
Exactly. And if it's clear out where you are, we'll definitely go out and look at the moon in the sky and take us outside with you. If it's cloudy, well, hey, we're going to show you live views of the lunar eclipse as it's happening.
Yep, we've got lovely clear skies here in Carbondale still. Looks like they're holding out so far. And that's perfect for the start of this show, because we started this show just a few minutes before what's called second contact, the partial phase of this lunar eclipse beginning tonight. So we've already got a live telescope view of the moon here for you on the stream, where we are starting to see that darker shadow beginning to come up from that bottom part of the moon that you see on the stream here. So we're 1 minute earlier than I was expecting to see the partial phase start. Why does it already start to look like we're getting some darker shadow coming in on the bottom?
So the moon, the shadow of the Earth on the moon is kind of fuzzy, and so the sun is an extended object, the moon is an extended object, and so when you get all that combining together, you get kind of a fuzzy edge shadow, not a really crisp shadow edge. And so you're gonna start to see a bit of that moon look a little bit darker. And the moon has, before we started the show, the moon was already going into the lighter outer shadow of the Earth. And so we're going to talk more about those different kinds of shadows in just a little bit.
Yeah, so you might have noticed that we called this second contact, even though we're really referring to this as the start of the lunar eclipse happening. So that is because there's really these multiple different portions of a shadow. So while this may not be the real Earth or the real Earth's shadow being cast into space. This does a really good job of showcasing those darker and lighter portions of the shadow here. So you see that dark inner shadow that we call the umbra, and that lighter, large shadow around the outside called the penumbra. Why do we have these different portions of a shadow?
Yeah, so the sun being a wide thing and the Earth being a wide thing, you've got the light from the sun shining on the Earth, and so you've got the shadow kind of being spread out at the edges for the different parts of the sun, creating the shadow. And so you get a fuzzy edge shadow, which you can, your fuzzy edge shadow and different parts of the shadow. The lighter outer shadow is where, if you were within that shadow looking back at the sun, you would see part of the sun covered by the moon, or by the Earth, excuse me. If you were within that darkest inner shadow, you would see all of the sun covered by the Earth. And so that's why we got those two different parts of the shadow.
Right. Now, you know, with that lighter outer part of the shadow, it's a little tough to notice when the eclipse is starting. We honestly, because it was so clear here, we really could start to see it even with our eyes, but really that distinct, you know, bite being taken out of the moon really starts with this partial phase as the moon moves into that umbral shadow.
Exactly. Yeah, you had to, we were standing here, it was about half an hour before the show started, and we're going, yeah, I think I see it. I think I see it. Because we knew it was happening, so if you didn't know it was happening.
If you had known it was going on, it might have been a little tougher to see, but if we take a look at that telescope view tonight, you know, we have that darker part of the shadow, that bite coming out of the bottom portion, but you can see that some of those upper parts of the moon as well, like about halfway through, you can see some of those darker areas from the penumbral shadow, but it's much less distinct than that dark bite starting to get taken out.
Not a really hard edge. You have a gradual kind of increase in darkness there, and then you get into the darker inner part, and you can really start to see that in our image. That looks really cool.
Right, it really is looking great. Now, we've got quite a long time for this partial phase to continue on. Lunar eclipses are a little easier to observe than some other things in the night sky, and you know, whenever if you're a Sky Observers Hangout regular in the chat tonight, you know that we love to observe alongside you. We always encourage you to take us outside with you and look up at the night sky right alongside us, and a lunar eclipse is one of the perfect nights to do that.
Exactly.
You know, we have, since we're down here in Carbondale, we've been talking a lot about the solar eclipse last year as well, but you know, that one can be pretty tough to spot. Takes a lot of hard work to catch a solar eclipse. That's why you have all these eclipse chasers out here. What makes a lunar eclipse so much easier to see?
Well, we've got basically our entire half of the Earth. Is as long as you can see where the moon is in the sky. If the moon is up in the sky for you right now, the moon is passing through the Earth's shadow right now. So as long as you can see the moon, you can see the lunar eclipse. You don't have to be in as small of an area because the moon's shadow on the Earth during a lunar eclipse or during a solar eclipse is much smaller. The Earth's shadow that the moon is passing through is going to be bigger, so you're going to have a much easier chance of being able to see this.
Right, so on the screen right now we have a map from Time and Date, a website that we love using for predicting, you know, they have really nice predictions for all kinds of things, eclipses, sunrise, sunset, lots of astronomical related things. And you can see this one covers this entire swath of the Earth, right, this entire half of the planet. Anywhere that has the moon up in the sky right now is able to see this lunar eclipse happening right alongside us. Now,
and where it's shaded in that darkest pink area in the middle, or purple or ish, whatever that color is, that's where you get to see all of the lunar eclipse. Where you get into those edges there, that's where you might miss part of it. So it might set for you during totality, or it might set for you during the last part of the partial phase.
I think actually everywhere in the Americas today does get to see all of totality, I believe. Maybe some very particular little regions that are going to miss a little bit of the partial phase. I think even these regions are still seeing all of totality, just maybe not some of the partial. And actually even some places in Eastern Asia and Western Africa and Europe are able to see some of this lunar eclipse tonight. But do not fear, if you're joining us from some further away places not in the Americas, you've got another lunar eclipse coming up later this year in September. So we have another map here from Time and Date that shows that one happening later this year. So pretty much everywhere that is missing the total lunar eclipse this time gets to see this one later in the year. So lots of opportunities for lunar eclipse observations. And even if it's cloudy where you are today and you're in the Americas, we've got another one coming up next March too. These are much more common than, you know, things like these solar eclipses that we see. So lots of chances to check out a lunar eclipse.
So speaking of, check out our awesome view. This is live from Richard Manning, our telescope here at the Southern Illinois University campus, and it looks really cool. And speaking of going and actually looking, I want to peek and take a look.
Oh yeah, I haven't looked yet either.
We have a tent over us right now.
Looks lovely.
See?
Now, while we do have this telescope view tonight, and while it may provide some more detailed views, especially this one that's even a little bit more magnified than the last one, watching it march its way into that shadow, this is something that you really don't need any special equipment for. Sure, a telescope or some binoculars might amplify your experience, but this is one that is really, really wonderful and exciting to see with just the naked eye, right?
Yeah.
I mean, everybody knows how fun it is to go outside and appreciate the lunar eclipse, but or appreciate the moon, and that's no different when it comes time for a lunar eclipse. Now, one thing that people might be wondering is, do you need any solar viewing glasses? Because we call these eclipse glasses, right? We only needed these because the sun is incredibly bright, and during some phases of the solar eclipse, you're looking straight at the sun. Don't worry, don't need that for a lunar eclipse. It's actually getting darker than the moon usually is, so nothing to be worried about tonight. You can go out there and start observing right away.
Yep, save those solar glasses for the next solar eclipse. So you can put those away. Just go outside. If you can see the moon, you can see the lunar eclipse. And basically, the rule is if you normally look at the moon with just your eyes, a darker version of the moon you definitely can look at with just your
right,
eyes.
Exactly. Now, one thing as far as the equipment goes that we do often get asked about is that how can we take better pictures of the moon during a lunar eclipse? And Michelle, I know you're pretty experienced with that and have some good recommendations for taking pictures.
Yep. So first off, most of us are probably going to be trying to take pictures with our phone. And actually what you may have noticed if you've ever tried to take a picture of just the moon in the sky or the full moon in the sky, just the regular full moon, it's pretty bright. So the first thing you want to do also, and it's kind of hard to find it. Okay, first thing, take your phone out, brace your arms. You might want to put your arms on if you've got a bench or a table or fence or something, or put your arm up against a tree.
I was gonna say even leaning back against a tree can help.
Yep, leaning in a chair, just brace your arms in some way. If you've got a little camera tripod for your phone, great, but even if you don't have that, a stack of books would work fine. So that would help keep your hands from shaking. Secondly, the moon can be pretty bright, but it's getting darker during the lunar eclipse, so that's good. But it may still be a little bit bright. So what you want to do is tap the image of the moon on your screen and drag your finger downward, at least for the iPhone. We both have iPhones.
A lot of other cameras have very similar kinds of controls. When you tap on it, it auto focuses. It'll bring a little box up on the screen, and then you'll have like a little bar next to the side. I think on iPhones it even has a like almost like a little image of the sun on there.
Yep.
That's where you're adjusting that brightness, that exposure time.
You might have to take it down just a bit, but as we get closer and closer to totality and it gets darker and darker, you'll have to do that less. And so you just might have to adjust those settings just a little bit. You might have to adjust the exposure time. So some of the later phone models, you can have exposures up to 1 second, 2 seconds, 3 seconds, maybe even up to 10 seconds to be able to adjust the exposure time. However, just be careful with that, because the longer the exposure time gets, the more chance you have for a blurry image. The moon is moving in the sky, and so that does make a difference. So try to keep that exposure time down to at least 2 seconds or less if you can.
Now, the nice thing with the lunar eclipse is you've got a lot of time to mess with these settings, work on getting the perfect picture, because this is an event that's going to last a few hours. We're going to be getting pretty late into the night by the end of it, or early into tomorrow morning by the end of it, but you do have lots of opportunities to do this. It was hard for me to recommend with the solar eclipse happening, people taking pictures during totality, because you got limited time and I want to make sure you can go out there and appreciate it. With the lunar eclipse, great opportunity to get some great photos of the moon. Now, before we continue too much further, I want to answer some wonderful questions that we're getting in the chat. So we had a few questions about what is a blood moon? Would this be considered a blood moon? And right now we might not be able to notice the connection between blood moon and a lunar eclipse, but as we approach totality, that will start to become a little bit more clear. Yes, that is what we will be seeing later tonight. Why do we call total lunar eclipses blood moons?
Well, It actually is a term that's only been around for a handful of decades. It's a really recent term, and it just sort of has become synonymous with lunar eclipse. It's not an astronomical term, but some people going, oh, the moon kind of looks like it turns red during a lunar eclipse, so blood is red, and so therefore it be called blood moon. So yes, you can call it that, but it isn't a term that you'll necessarily see in an astronomy textbook.
Right.
But yeah, just one of those everyday kind of terms that you might use to refer to a lunar eclipse.
So yeah, stay tuned for another hour and 6 minutes, and you will be able to tell why it gets that name.
Exactly.
Start to see some of that red color coming into view as totality hits. See, well, that's true.
Maybe.
We'll see what exactly it looks like tonight, but we'll talk more about that.
Yep.
One other question we had in the chat is, are tides affected by lunar eclipses? So that's an interesting one. You know, we know that the tides are caused by the moon orbiting around the Earth, right, and the gravitational pull that it is giving us. But what about during lunar eclipses? Is there anything special going on during this that would affect it anymore?
Nope. Simple as that. Not really, because tides are affected by the moon, and tides are affected if it's a full moon. But full moons happen every time the moon goes around the Earth, and so there's not really anything terribly noticeable that you would see with a full moon and a tide during a lunar eclipse. But just know that yes, the moon causes the tides on the Earth. But no, nothing that I'm aware of, unless Geza knows of something that he might want to put into the chat for us.
Yeah, I don't know. I don't know if like the perfect alignment of these things would change anything. You know, really, there's not so much different going on during a lunar eclipse compared to your average full moon. You know, the alignment is just right, but I can't imagine that it would make too much of a difference on the tides compared to a regular full moon.
Maybe a little bit
based on its position.
Yeah. By the way, those of you in Chicago, if you're wondering, hey, any difference on the tides on Lake Michigan? Have you ever seen a tide on Lake Michigan? Probably not. Probably not.
I've seen waves.
Yeah, you've seen waves, but the tides on Lake Michigan are only about a centimeter tall. So, yeah, don't really notice much there.
Now, one other thing we wanted to mention, you know, all of us are outside, you know, spending these couple of hours outside tonight. And while we're still in the early phases of the partial phase, you know, before we really want to be focusing on the moon, I also want to talk about some of the other things that we can spot in the sky tonight, because there's so much more than just the moon out. So in this view, you can see the moon up in the top left corner, but this is looking southwestward, and the moon can help you kind of position yourself in the sky. So we've got lots of things to look at in this direction right now, and this should be for, I think, right around this time. I set this to around 12:30 when I took these images. This should be pretty close to what we're seeing right now in the sky.
For the central time zone.
For the central time zone, yes, exactly. So a couple things you might notice, a few planets that we can still see up in the sky. Jupiter getting very low to the western horizon. It's on this simulated tree in Stellarium here. But you'll also notice another planet, Mars, right within the middle of the Gemini constellation. It's been making kind of a really striking triangle with the two stars Castor and Pollux that represent the heads of the Gemini twins.
Yep, so if you're going outside, just to get your bearings, if you're facing the moon, look to the right.
Yes.
And so those of you in the Eastern time zone, what you see in this image, shift everything over to the right a little bit more. So everything to the west will be in a little bit lower in the sky.
So some of these things will be starting to set in the Eastern time zone, but if you're on the Western time zone, then some of these things will be a little higher in the sky, and you might have an easier time spotting something like Orion that you can see really low on the horizon here in Illinois, but could be much higher up in the sky in other places.
Correct.
Some other bright stars that we have here, Capella in the Auriga constellation, the very, very bright Sirius, brightest star in our night sky up here in the northern hemisphere, as part of Canis Major. So lots of good stuff to look at. And then if we head over to the opposite side of the sky here, this is looking north. Not so many planets to look at, but still some very recognizable constellations that you might see. Ursa Major, containing the famed Big Dipper that you might be very familiar with.
Almost overhead. So,
yes, very high up.
So when you go out, no matter where you are in the northern hemisphere, go out, face north. If it's dark out right now, face north, and the North Star will be whatever your latitude is above the horizon.
Right, that high in the sky.
So yeah, it'll be that high in the sky. So for Chicago, 42 degrees north latitude, the North Star is 42 degrees up. And so the Big Dipper will be up even higher than that. So yeah, just in the United States right now, the Big Dipper will be fairly high overhead for most of us.
Yep. Last one I'll point out here is Boötes is another pretty distinct one that has a fair few bright stars, particularly Arcturus. So lots of stuff to go out and look at tonight. Obviously, we'll mostly be distracted by the moon, but tons of other beautiful things to look at.
Yep.
Now, I love this question. I see that Geza already answered it in the chat, but this is a really good one, so I want to bring it up anyways. If you were on the moon viewing a lunar eclipse, what would it look like?
Well, right this very second, what it would look like is a partial solar eclipse. Because the Earth, as seen from the moon, is covering the sun. And so you would see a partial solar eclipse right now. So if you were on the moon and you had your solar glasses, you could see it. And you could see the partial solar eclipse. But there is a spacecraft on the surface of the moon right now, and Blue Ghost, and so it
just landed recently. You might have seen that in the news.
Exactly, and it's going to be taking pictures during the lunar eclipse. So I actually don't know what it's gonna
I'm really
look like.
excited to see that. You know, these eclipses all happen because of this alignment of these different objects, and you know, whether we see a solar or lunar eclipse is based on the order of those objects, right? So before we were seeing a year ago during the solar eclipse, we were seeing the moon block our view of the sun, right? And so if you were this time, the Earth is in the middle of that alignment, right? So when we're looking at the moon, we're seeing the Earth's shadow being cast on it. So you can imagine if you're on the moon, yeah, the Earth's got to be in the way, right? It's right there in the middle, giving you a view of a solar eclipse from there.
Exactly.
Really exciting.
And during totality, during the lunar eclipse, if you were on the moon, it would look like a total solar eclipse. Although I wonder how much of the corona would actually be visible.
We'll see. Yeah, I'm really curious to see what those pictures look like when they start coming back.
Yep.
Now, you know, since we're down here in Southern Illinois, we wanted to bring on some special guests for the show tonight.
Yep.
Some folks that we can only get down here when we're in Southern Illinois, not when we're up in Chicago. And so the first one that we want to bring on to the show is someone that I think can provide some really unique insights into finding dark sky locations. So we're talking about what we can see in the night sky, right? And, you know, on the map that we were showing earlier, all of those stars are not visible from up in Chicago, right? When we're up there and we have so much light pollution. So we love to talk about some of these park places that we can go to, some of these dark skies that we can reach. So we want to bring on Steve Vasicek, an Illinois Conservation Police Officer down here in Southern Illinois, who will join us to talk a little bit about what he does.
Yes.
Hey Steve, welcome to Sky Observer's Hangout.
Join us.
Thanks for having me.
Yeah, thanks so much for coming.
This is great.
So as you can tell, Steve is currently on duty tonight,
I am, I'm
we
working.
really appreciate
Loving
him
this opportunity.
coming out to the show.
It's really cool.
So to start off, why don't you tell us a little bit about, you know, what it means to be a conservation police officer?
Well, conservation police officers in Illinois, we have full police powers like state police, but we also have all these extra duties of like fish, wildlife, ginseng, timber, water resources, all those things. So we do everything that regular police officers do, and then the whole resource side of it. So we're kind of like the Swiss Army knife of police officers. So we get calls from anything from a raccoon on a porch to chasing down somebody who's, you know, attempted murder or something.
Oh, so my goodness.
It's crazy.
So you keep the people resources safe, you keep the resources safe.
It is.
Yeah.
And we get to deal with a lot of non-consumptive users too, you know, bird watchers and, you know, people that like viewing the night sky. So we meet all types, and
That's cool.
it's really fun.
Yeah, and I'm
awesome.
particularly interested in some of this like conservation and wildlife side of the job. That's not something that you often think of when you hear, you know, police officer, right?
Right. Yeah.
So how does that come into your work?
Well, you know, we enforce all the fish and wildlife laws, so we obviously work in remote places. You know, my district covers, you know, both the Mississippi and Ohio rivers and everything in between. So Shawnee National Forest, we have Cypress Creek National Wildlife Refuge, Crab Orchard National Wildlife Refuge, and all the state parks and things. So there's so many wildlands down here that there's plenty of nooks and crannies for us to kind of poke around and keep everybody safe.
And by the way, for those of you in Northern Illinois, if you aren't aware, Illinois has the northernmost cypress grove in the United States, and you can come and visit. It is really
Good
cool.
point.
Yeah,
Bottomland hardwood, cypress swamps.
you would almost think you're in Louisiana, but you're not.
You know, it's kind of amazing because a lot of the people I don't want to overgeneralize, but down here they kind of take what they have resource-wise for granted. But then when they come down here and visit Southern Illinois, like, oh my gosh, this is my state.
It's
because it's like the
beautiful.
unglaciated, there's topography, you know, it's a really neat place.
It
so
is beautiful.
I love showing people around down here, and you know, sending them to the coolest spots, and you know, they love it. So.
Good food down here too.
And you know, as astronomy enthusiasts, we know that you know, people can have a big impact on the nature around us, including the night sky, right, with all of that light pollution. So folks like you really help keep that stuff safe. Now, outside of being a conservation officer, you know, you're also an avid amateur astronomer in your free time too.
I love the sky.
And so, yeah, tell us a little bit about your relationship with the night sky, what you like to go out and observe.
My parents brought me and my sister out for different astronomy events, and we viewed, you know, the rings of Saturn. We were always out for the different meteor showers, the Geminids and Perseids and things like that. So try to make all those things that you can, you know, because it's just, you know, that's how you stay humble. You know, just seeing what the universe is like. So it's been really neat. It kind of connects you with everything else even more when you can view the sky.
So you've been doing this since you were a kid?
Yeah, you know, sometimes when we were, you know, looking through, what are the Dobsonians?
Yeah, absolutely,
Like
exactly.
Dobsonians,
I'm sure the Sky Observers Hangout regulars have certainly heard
usually
that
I'd have
before.
a catfish pole out too, and I'd be fishing also. But you know, we'd also be looking at things. So you know, it's so wonderful to get young people involved in this stuff, just to stretch their mind, you know, and expose them to this type of thing, you know, just so they can keep an open mind about things. So.
Yeah, and you know, one thing I didn't really appreciate so much until I started working with the Adler, and this is something that you really exposed me to, is how much the night sky is a part of nature around us, right? Just because it's much more distant than the nature that we're used to down here on the Earth, it really is so ingrained in all of that nature around us and with the Earth that we live on.
It really makes you appreciate everything you have even more, you know, by stretching your mind about this kind of thing.
And being able to see a dark sky helps to connect you more with that. You notice, you see more stars, you see more stuff.
Absolutely, and a lot of people that come from the city and visit down here, like, they are amazed at how many stars we can see just because there's not much ambient light, and it's just like they're taken back by, like, oh my gosh, I've talked to people who literally have never seen stars before. You know, and it's just like, wow.
And you see a star-studded sky like you get down here, and it's impossible to miss, right? But you know, I think you get to one of those dark sites and you see those really star-filled skies, and you go back home to your more light-polluted skies, and you're more attentive of it, and you realize, oh wait, there are some things I can see here. It just takes a little harder work. You got to pay a little closer attention, right?
And it connects you to everything else even more.
Yep.
Now, when people ask us about dark sky locations, you know, many of the places that we recommend are parklands, right? Those are a lot of the darkest places here in the United States. Do you have any tips for viewers at home on how they can find dark skies in parks and how they can best utilize those resources? Because sometimes it can be tricky making sure that you're, you know, following all of the, you know, proper rules in parklands related to nighttime observing, but also taking advantage of those dark skies that are a really valuable resource that parks can provide.
Yeah, and I appreciate people coming down for that purpose, because, you know, we have a lot of consumptive users like fishermen, hunters, things like that, but when people come down to visit to view sky and things like that, you know, some things to keep in mind are, like, the Shawnee National Forest is, you know, approximately 300,000 acres down here, and you know, you can camp there for 14 days anywhere in the national forest. So even if it's not a campsite, you can camp there for 14 days. You know, probably one of the biggest considerations is you know, ticks. Not necessarily this time of year, but, like, you know, people overlook that thing, and, like, during some of the solar eclipses, you know, there's people who, you know, weren't aware of the tick-borne illnesses and things, and they're going through the grasslands and things, and, you know, they're covered. And next thing you know, there's so many tick-borne illnesses, you know, Rocky Mountain spotted fever and ehrlichiosis and Lyme disease, and those are serious things, you know. So being aware of insect-related diseases and preventive on those, that's a big one.
Coming prepared for sure. Yep.
And we have a lot of well, we have 3 different kind of venomous snakes down here, so if you're walking around at night, you might want to be aware of, like, cottonmouths, copperheads, timber rattlesnakes, things like that. So and then, so we'd have the national forest, we have state parks, we have a state forest down here, we have all the different refuges that you can camp. So IDNR does a wonderful job of hosting people at the campsites, and it goes through Explore More Illinois. If you get on the website, if you want to have like a regular campsite, you can get reservations through Explore More. And our administration has done a great job between our governor, our director Finney. They're a huge proponent of all people using our spaces, so it's worked out great.
And just to add for folks in the Chicagoland area, because we get asked where can people drive to in order to see a dark sky, there's a couple places that we recommend. One of which is in Champaign County, which is a county park, Middle Fork River Forest Preserve, so it's about 2 hours south of Chicago. But there's a state fish and wildlife area, Green River, which is west of Chicago, and so about 2 hours west.
Lee County, maybe?
Yep, yep. So out that direction, and a lot of the amateur astronomers in the Chicago area head to the Green River area. So, but the Explore More Illinois and the IDNR site, I go there all the time for the maps and the hiking trails and all that.
Licensing and things like that, all the opportunities. Another thing to consider, and I have a story about that, is when I was in college down here at SIU, we went to Panther's Den, which is a place in the Shawnee that's really remote, and we decided to go for a night hike. And so there's cliff faces and things here, so there was a lot of moonlight. We were walking along, without a flashlight, and we happened to turn our flashlight on, and there was a cliff face right there. So, if people do come down here, just be very cautious of the topography, because,
Turn your flashlights on, folks.
Yes, because, there might be a rock slide or a cliff or something, so, that's a good tip.
We're glad we didn't lose you then.
Yeah, that would have been good.
Now, being back down here in Carbondale, it's been unavoidable thinking about the total solar eclipse last year, especially while this may be a lunar eclipse, it's still got that shared name. So I've asked pretty much everybody I've seen in the last week this question: how was your total solar eclipse experience?
It was amazing.
What was yours like?
Amazing. I was actually in a boat on Cedar Lake, and I was in the cove where the two eclipses crossed. So there was a buoy out there, and it was the exact point where they crossed. So me and Forest Service Officer Anderson Harris were out there in a boat. So it was amazing. It was just kind of an out of body being on the X of the two paths.
And someone put a buoy in that spot, so
they did. Yeah,
oh, that's cool.
Yeah, I know Joe McFarland, one of our writers from DNR in the past. He had a lot to do with that, so
cool.
That was really neat. And all the birds started chirping, and
I know. Yeah, we've heard so much about the animals reacting and it getting dark around you, and it's been giving me chills all week, honestly.
Yeah, well, you don't remember years, you don't remember months, you don't remember days, but people remember moments.
Yep.
And like moments like tonight or that solar eclipse.
There's few moments more special.
Yes.
Moments like when my mom and dad, we took the telescope outside when I was 8, and it was my brother's telescope, and I saw Saturn for the first time.
Really?
It's still burned into my brain.
Amazing. Same with the Aurora Borealis.
Yeah, exactly.
First time in Wisconsin, the lights shimmering. I was about this tall, and my mom and dad were like, "Oh my gosh," and it was.
And for those just joining us, we're on the campus of Southern Illinois University Carbondale in Carbondale, Illinois, and we saw the total solar eclipse from right over there.
Yep, we can see the stadium that we were in from where we're sitting.
Yeah, it was amazing. It was awesome. So.
Well, Steve, we really appreciate you taking time out of, not only your day, but your work day to come out and talk to us.
I would do it anyway.
We really appreciate it. So yeah, thanks so much for coming on. Hope you have a great rest of your night tonight.
Enjoy the rest of the eclipse.
Yes, enjoy watching the rest.
All right.
Well, that was great. I learned so much having Steve on. That was really wonderful stuff to hear, and getting to hear some of his experiences too is so wonderful. Every story that people have told me, not only about the lunar eclipse, but about the solar eclipse last year, has brought back so many memories. Now, we had some really great questions coming in, but while we were working on that, so I wanted to mention some of those. I think a lot of them were actually related to the same kind of thing. So some people were asking if this is a live shot of the moon from Carbondale. Yes, absolutely. All of the feeds that you're seeing are from 3 different telescopes that we have set up here tonight. You'll see like almost different fields of views that we've got going tonight with a few different telescopes. But one thing that people have been mentioning is that the moon looks different than it looks in their sky. It looks flipped. I would guess flipped horizontally is what we're seeing here.
Right.
So what's going on? Do we have a different moon here in Carbondale, or what's the trick here?
No. So first off, this is a telescope view, and so telescopes are going to flip an image, but also you might see the image rotated a bit, and that's because the camera that's on it is depending on how you rotate it in the eyepiece, that can determine how you actually see the moon. So yes, it will be either flipped or rotated.
So it can be rotated in different ways, but then also, you know, when we start to have things like lenses, right, all of this glass, or with other telescopes like we have at the Planetarium with mirrors and things, you'll see flipped images and things. Now, there are things that we can do to, you know, keep this look at this image looking the same as it does in the sky, right? We can add extra elements inside of the telescope, right? But the more elements you add, right, the better chance you have of lowering the quality of image you're collecting, right?
That's a good point. We get asked that a lot, where someone says, "Oh, can you put something on the telescope to flip the image?"
Right.
And you can, but you degrade the image in the process. You scatter some of the light away. You take some of the light away when it passes through or off of another surface. And so this is, a lot of times we're looking at dim stuff, and you make dim stuff even dimmer. And so if you're looking at a map of the moon and you're looking through a telescope, just flip your moon map.
Right, exactly. Yeah.
So it's nothing that we tend to really worry about exactly matching what people are seeing in the actual night sky.
Right. What I always say is, you know, there's no right side up or upside down in space. And you know, if we really want to work on it after, if we take pictures, we can always flip them around after the fact. No big deal. So good question. Yes, this is still a live view. If I look out here in the sky, which I can just barely see it still, before the tent's gone. Yeah, go ahead and take your look. It is flipped in the sky for us here too. And actually, if you look at the moon when it rises versus when it sets, you'll also even see some rotation then too. So, you know, the direction that the shadow's coming from will change as the lunar eclipse progresses. But yes, these are all live telescope views that we are getting tonight.
It is a little bit hazy.
It is a little bit. I will say again, now that I'm looking out, I am seeing some of those faint clouds coming in, but you know, fortunately, that shouldn't cause too many big problems for us tonight, because the moon is really bright, thankfully. You know, this is not one of those dim objects like a galaxy that we're trying to look at, where like some hazy clouds would be a major issue. Fortunately, you know, not a big deal for this one. Nothing brighter than the moon in the night sky, right?
Correct.
Even if it does get a little dimmer as the lunar eclipse happens, right? All right, now, as the partial eclipse continues, one thing we want to talk about is how exactly these lunar eclipses happen. So we want to start that off by doing a little demonstration. You know, while we can talk about how these are lining up and all of those things, I think it really helps to see visually how these objects are organized to make these things possible. So we have a little short about recreating a lunar eclipse that we're going to play here next. And it's actually a really easy activity that you could even try at home if you want to recreate one yourself.
Exactly.
So, what makes a lunar eclipse possible? It's all about alignment. Let's set up a demonstration to help us understand just how this happens. This ball, which is 1 foot across, will represent the Earth today. With the Earth this size, how big would you expect the moon to be? It looks so big in the sky compared to all of the distant stars and planets, but really it's quite small in comparison, only 1/4 the diameter of the Earth. These two sizes are accurate to scale, but distances in space are a little harder to represent. You might think that holding them far apart like this is distant enough, but in reality, I would need to be all the way over here for this to be accurate. If the Earth was only 1 foot wide, the moon would still need to be over 30 feet away. We haven't even made it to the hardest part yet, representing the sun. At this scale, the sun would be 109 feet wide and over 2 miles away from me. It's important to remember that distances in outer space are vast. For our lunar eclipse demonstration today, we'll use these scaled down sizes, but our distances will be much shorter than they really should be. As the moon orbits the Earth, we see it go through different phases. When the moon is opposite the sun in the sky, we see a full moon, where the entire side of the moon facing us is illuminated by the sun. Every once in a while, though, a unique alignment occurs on a full moon where the sun's light isn't able to reach the moon's surface.
That's because the Earth gets in the way. When the three objects, the Sun, the Earth, and the Moon, line up perfectly, the Earth casts its shadow on the Moon, causing a lunar eclipse. You can watch as the Moon gradually dips into the Earth's shadow, plunging into darkness as totality begins. Now, you might be wondering, why don't we get a lunar eclipse every full moon? That's because the Moon's orbit is tilted with respect to the Earth's. This means that most of the time, the Moon's orbit misses the Earth's shadow. For me, this makes this unique lunar eclipse alignment feel even more special, so don't miss your chance to see one.
All right. Well, now that we have this better idea of, how lunar eclipses are really happening, right? That we're seeing the moon pass into the Earth's shadow, I really think it helps give some better perspective on what's going on tonight. Now, before we continue too far on in our regularly scheduled program, we had a good question here. Someone wanted to know totality start time for Florida. So one thing that's really unique about a lunar eclipse is that if you are here on the stream with us and you see totality starting here, it'll be starting at the same time where you are. So the time zone may be different, right? But the timing, since we're all here online together, will be simultaneous. So for here in the central time zone, it'll be 1:26. For you on the eastern time zone, that'll be 2:26.
Yep.
But if you're here with us on the stream and you see totality hitting here, it's hitting where you are too.
Yep, and so that's 1:26 a.m. Central Time.
Yes,
2:26 a.m. Central Time. So 12:26 a.m. Mountain Time, 11:26 p.m. Pacific Time. So it's all going to happen at the same time for all of us. It'll just be the moon will be in a slightly different part of the sky in a different time zone, and the clock time depends on your time zone.
Right.
But it's happening at one time.
Yep. So if you hang out here with us on stream, you'll know exactly when it's starting.
Exactly.
We'll let you know when you should make sure you get outside.
Yep.
Now, thinking back to, the alignment that happens with a lunar eclipse and the things that we're seeing tonight, seeing Earth's shadow cast onto it, this information has been really helpful throughout history, and it's actually, been astronomically important for some new discoveries, right? So can you tell us a little bit about what we've learned from lunar eclipses throughout history?
Well, the first thing we learned was what the shape of the Earth was.
Right, that's a big one, right? Sometimes we take for granted how much information we have available to us these days, right?
Yeah, exactly. So if you go outside, if you can see the moon right now, look at the shape of the shadow. The shape of the Earth's shadow on the moon is curved. And so the ancient Greeks, other folks knew that the Earth was round because of that curved shadow. No matter where the moon was in the sky during different lunar eclipses, the shape of the Earth's shadow was curved. And so the only way you can get that, where no matter where the moon is and no matter where you're viewing it from during a lunar eclipse, no matter what time it is, the shape of the Earth's shadow is curved. That means the Earth is a sphere.
Right. You can imagine, if you take a circle and turn it sideways.
Right.
Well, now it's just a flat
Now
line,
it's just
right?
it'd just be a flat line.
The fact that we could always see these being that same exact shape every time.
Right.
Only one shape exists that does
Ancient
that.
Greeks knew, people knew, mariners knew, people knew the Earth was round, and they really did. And so that is one of the prime ways that we actually do that.
And it takes these kind of, special moments to be able to discover those kinds of things.
And what's also really interesting is the ancient Greeks, they knew that it was the Earth that was causing that shadow. They figured that out. And so they were no dummies.
That's a lot, hey, they had same brains that we got now. We've just got a lot more access to information, right?
Exactly.
Now, another thing, while us here tonight, may not be doing any research with the lunar eclipse. We're clearly still very excited to come out and observe, right? And it's really an observer's phenomenon for a lot of people today, right? And one thing that I wanted to talk about a little bit too is that it's been really important for, getting people excited about the sky, right? Just like we were talking with Steve, that these things get people outside looking, and then that can create these lifelong observers that continue to go outside and appreciate astronomy. And, while they didn't have live streams like we have today to share information about lunar eclipses and about the things going on in the sky, it was still something that people were really interested in doing. And we had a couple of, for folks that have been to Sky Observers Hangout in the past, you may be familiar with our Collections Corner segment that we do, where we give a special sneak peek into some of the objects that we have at the planetarium that tell us about the history of astronomy observing, right? And the first one we want to bring up here is something called a tellurian. So this is something that is used to demonstrate just how lunar eclipses were happening, and actually solar eclipses as well, much like we were doing in the video today. So can you tell us a little bit about like some of the things that we're seeing on here?
Yeah, this is one of my favorite objects in our collection. So the Adler Planetarium has one of the world's foremost, most wonderful collections of astronomical instruments and books from the past. And this is a model of the sun, the earth, and the moon. And if you're going, wait, I don't see the sun. Well, if you see that little tube that is kind of to the upper right on to the right side of the image, so there's that little stand.
Like coming out of the stand.
Yep, that little tube that comes out of the stand, that is meant to hold a candle, and that would represent the sun. And that little curved piece there on the right-hand side, that would help reflect the sun's light back toward the model of the Earth. And you can see the Earth globe there. And the little ball hanging off the top, that's the moon. And so as you turn the crank, and you can see the crank below that curved piece that would reflect the candlelight, you turn that crank, and that turns the Earth, and it turns the moon around the Earth, and it turns the whole thing around the sun. And so this was a really fantastic teaching model to help people understand how this arrangement worked.
I gotta say, their model looks a little fancier than the one that I made with a kickball and a stress ball. My version of a candle was a ring light. So ye old ring light here on the stand.
Well, I wonder, will yours be around in about 300 years?
That's a good question. That's a good question. Now, another one that we have here that was also used in a very similar way is these lantern slides that were used to project images of eclipses.
Yeah, I love this. I love this.
Oh man, one of my favorite days of the Adler was when they got some of these out and like remade one of these old projectors to see these.
Yeah.
So they would project these up on the walls and do presentations very similar to what we were doing today, right?
So if you think about how we view imagery now, it's all digital, right? It's digital screens, digital projectors, all that. Back in the day in planetariums, when planetariums especially first started, and even before then, how would you project imagery? Well, you would create a single slide. You might it might be through photography. It might be even before you could do that reliably. You might have painted something on a glass slide and have a light, a candle, something on the inside of a container. You stick the slide on it, and the light would project your image onto a wall. And so this is called a lantern slide, because you would use a lantern to light up the slide. And so you can see the arrangement of the sun, the earth, and the moon at a few different times. So the image on the right is the sun, the moon, the earth, for a solar eclipse, and then it's also for a lunar eclipse if you see the moon is in the Earth's shadow there on the right hand side. Yeah.
So I like looking at this because one of our sayings at the Adler is that we're under the sky we all share, right? It's not just the sky we share with everybody around on the Earth today. It's the sky that we share with folks that were living hundreds of years ago too, and it's things that have brought this awe and wonder for centuries, millennia. It's something that has always had a close connection with humans and has always gotten us excited. And I feel like today we are maybe even losing that a little bit more than people have in the past. So everybody that's here today, you're keeping that love alive, that appreciation for the sky, and that's nothing new.
Exactly. And I'm looking around here on the campus of Southern Illinois University Carbondale, and we've got folks here. I just saw some more cars drive in.
And I can see some shadows in the distance. The lighting right on us makes it a little hard to see out there. But there's one person out in the crowd in particular that we would like to bring on to the show next. Somebody that has really made the connection between SIU Carbondale and Adler possible. And so we would like to bring on, if you've been to some other streams that we've done in the past, you might have seen Bob come on at some points. But this is Bob Baer from Southern Illinois University.
Come on
down, Bob.
Let's go around, have a seat.
Thank you.
Thanks for joining us.
Thank you. Awesome.
What a night.
Bob
I mean, it has been beautiful. Now that I'm over closer to the edge, I can get another nice look.
And
It's looking
I can take
lovely.
another look.
Can
Yeah.
even start to see. I feel like I'm starting to see a little bit of that, totality color
Yeah.
coming in a little
There is
bit
a tiny
even.
bit of it,
You can
yeah.
see some of it on
You
that
can just
darker
see it.
part. So
It looks
everybody that's in the chat, get outside, make sure you're taking a look at everything that we're seeing tonight as well.
Ooh, can I sort of convince myself I see a tiny little bit of color in that image?
The image, it's a little tough to see. I
No,
can see
not
it
really,
honestly
but-
easier with my eyes, if I'm going to
Yeah,
be
that's true.
honest. Okay, well, I'm getting ahead of myself.
Sorry.
Bob, tell everybody at home a little bit about what you do down here at SIU Carbondale.
So I'm an associate scientist here at SIU Carbondale in the School of Physics. I do research. So I do solar research, citizen science. I do events like this, outreach events, which I love, and I work in, like I said, the School of Physics, also do research and instructional support here.
Now, well, over the last decade, I can't say I have worked with SIU Carbondale, but you two have been working together lots because of the 2 solar eclipses that were, visible here in Carbondale. This was really the crossroads of the eclipses, right? So how has being the crossroads of those 2 total solar eclipses impacted the work that you guys do here with the physics and astronomy departments?
Yeah, so starting 10 years ago, a lot changed.
Right.
I had done a Venus transit event, actually about in the same location. We had about 450 people show up, no advertising. It was like, wow, we might be onto something here.
Yep.
And so then, Michelle and I think we started working together in
2014. Mm-hmm.
And yeah, when I saw the map with the crossroads, and I was like, oh my gosh, we're seeing both of the eclipses.
Yeah, you're like, wow, we got a special opportunity.
Very. So yeah, that kicked off a lot of really cool stuff. Some of the research that I got involved in with at the time Syzycate experiment, which is now the DEB initiative, but also the opportunity to do outreach on a grand scale in the stadium.
Yeah, so we mentioned the stadium earlier. It's the university's football stadium. What's the capacity in there? It's like 14,000
people.
14,000. So, well, I'm assuming it was the same in 2017. I was here last year in 2024. It was packed. And it was, in 2017, I was in a more secluded area where I really got to connect with the nature side of seeing a solar eclipse. But wow, there was something so special about experiencing it along so many other people, and hearing the roar, the roarous applause when it started, and then a few seconds later, the complete silence, right?
The group experience is unique.
It really is.
And that helps explain why it is now almost 1 o'clock in the morning. And
we still got lots of people out in the crowds.
Dozens of people here.
Well, we've got we've had about 110 show up so far.
Wow. The people can view this anywhere, and they decided they wanted to come here.
Yeah, it's pretty
They wanted to hang out together. Yeah.
And 3,000 folks that have joined us online tonight. So, we've got so many people loving the lunar eclipse, and I know there's many more out there watching tonight. You know, these are things that really excite people. Now, one thing that you mentioned when you were talking about your work with SIU is the DEB initiative, and I think this is one that has been really interesting to me that you guys have worked on with the solar eclipses. So can you tell us a little bit about what exactly the DEB initiative is and what kinds of continued work you've also been doing since the solar eclipse?
Yeah, it's a Dynamic Eclipse Broadcast Initiative. I co-lead it with Matt Penn, and we have 82 science observation teams that observed the total solar eclipse.
Yeah, and so we actually have the homepage for the DEB project pulled up here on the stream right now, showing, these aren't all live views from tonight, although I can see a few lunar eclipse images in here.
That's Mike Conley in Oregon and Charles Greenwald in California observing the same eclipse that we're seeing right now. I think it's so cool.
That's so awesome.
But one of the long-term goals of the DEB initiative is observing white light solar flares, and we've observed 4 so far.
Really?
Wow.
Yeah, and it's really cool. So we've got data on 4. We've actually got a little bit of data analysis on one in particular on debinitiative.org right now, so you can actually see the white light, the signature of the flare.
Wow, so cool.
That's exciting.
Yeah, a solar.
And by
That's
the way,
super
those were
exciting.
not canned reactions from me and Michelle. Those
No.
were very genuine. That is
Seriously.
really cool.
Because normally you think of solar flares as high energy, higher energy light
Like
than
X-rays. and
visible.
yeah. The white light flares are a little more. Not all of them are white
Right,
light, so
right.
they're a little more rare to start with. But then the fact that we actually capture them with citizen science telescopes
Wow.
is wonderful.
That's awesome. And you know what I love about the Deb Initiative is, it really shows that there is, of course we have these huge observatories that are being built all over the world and space telescopes that are going out into space that have, way more power than we can pull off, here in Carbondale, anywhere in Illinois, right? Building a telescope that big here would be silly, right?
But so we have one really big advantage, right? We don't have to ship our stuff out into space.
right, that's a
And
huge
so
advantage.
There's
Right?
we can use fast cameras. We can test things. We can tweak our procedures. And so the resolution that we actually get, the time resolution, is very fast compared to some of the
Interesting.
larger scale assets.
But another thing that's great is, there's still so many things that we need to learn, even about these objects that feel so familiar to us, like the sun, right? And something like the Deb Initiative allows us to do more continued observation, right? Having many telescopes observing something that, isn't going to get time on a huge telescope, right? They're never pointing at the sun, right? And so, and especially during a solar eclipse where it was so cool to see all of the different views as the path moved along across the continent, right? And pulling up these different telescopes from different places.
But,
So-
the great thing is you've got dozens of these. There's several dozen of these scopes, and
Yeah,
so if it's
82.
cloudy here, it's going to be clear someplace else.
Exactly. And
somebody's going to get this data. So
that's a big part of the project, is being able to observe from different locations and picking up. I think we had 50% of the sites that collected coronal data, and some of that analysis is up to start with already too on debinitiative.org. And I think it's super cool because, again, like the resolution that we get is very high off of these little bitty scopes, and the time resolution's really high as well. So we're filling in some of those gaps in the data that we currently get from our
Can our viewers go?
space-based
Can our
images.
viewers go on debinitiative.org and see these images
Yes,
too?
they can. They're right on the front page.
Yep, so you can check all this stuff and go check out all these views, see what people are up to. It's always really exciting. If I'm going to be honest, I go and check up on there every once in a while and see what's going on, see who's been observing recently, and get some updated solar
So do we.
views.
We're like, hey.
Yeah, who's
are
been
you
doing
looking? So
That's
yeah,
hilarious.
it helps us a lot to have that page up actually.
That's cool.
Now, we talked about this a little bit, talking about the stadium show and things, but, here tonight, we have a lot more than just the live stream going on. We've got this public observing going on where anybody was able to come out and take a look through telescopes, watch the lunar eclipse alongside us, right? We also have some folks from the local astronomy club here, the Astronomical Association of Southern Illinois. So how does the university connect with local amateur astronomers to bring the sky to the public, and why is that something that has became so important to the university and your work in particular?
That's a really good question. One of the major things that we do that's in the mission of this university is community outreach, so serving the community. So that's why these events are free. The star parties that we do in partnership with you all are free. This is a service to the community, it's education, it's a partnership with the community, as you said, with ASI. They bring out telescopes, run them for free, interact with the public. I'm super appreciative that they do that we have these volunteers here running the telescopes. That's why we say it's guided telescope observations. And people are often like, do I need to bring my own equipment? Is it okay if I look at their stuff? I'm like, don't have to bring your own equipment, and we're here for you.
Exactly. Yep.
So it's
if you see a telescope, go look through it.
Yep. And that's, it's just been a great partnership with them. I'm a club member. I'm actually a board member of the club, and so I'm always talking up activities and saying, hey, who's up for this, and we always have people up for events like this.
And whenever we come down here with our Astro Road Trip outreach program, we always see we've got members of the Astronomical Association, the club, coming out and helping us out, and it really feels like whenever I come down here, and I'm down here at least once, twice a year, it feels like people think, even if they didn't go to SIU, they feel like it's their university, it's their clubhouse where they can all focus on and come to, that they know that there's something for them here, even if they didn't interact directly with the university. But actually they are interacting directly with the university.
Well, it's, in 2017, I think at the end of our observation, you remember Matt Kaplan had said, you know, you've just witnessed something together as a group. And our chancellor at the time said, we're all Salukis now. You know? We've all done this together.
Yep. I went to the University of Illinois, but I proudly wear my SIU t-shirt.
I do feel like an honorary member of the team down here, for sure.
Exactly.
And just anybody who's joining from Chicago, you know, I was mentioning the free programming that they do down here. Anybody up in Chicago, all of the telescope programming that we do in public observing is also always free and available to the public. Whether it's stuff happening right outside of the planetarium at the Doan Observatory, or whether it's our Scopes in the City outreach programs where we're visiting libraries and parks all across the Chicagoland area. We always make that free. We want you to come and look through our telescopes as many times as possible.
But it also means if you're ever coming down here to tour, to visit, if you're coming to come down for a little vacay, check and see if there's an event going on. You can come and take part. You don't have to be a local in order to do it.
We certainly don't. We love hosting people here.
Exactly.
Well, Bob, it is has been great to get the chance to talk to you. We're getting closer and closer to totality, so we got to do a little preparing for totality here. I imagine you've got some preparing for totality to do out there. So thanks so much for coming. We really appreciate not only you having us down here in Carbondale, but coming here and joining us on the stream tonight.
Thank you.
All right, have a good one, Bob. All right, now we did get a question from somebody in the chat about seeing our live view again. The telescopes are actually switching, I don't know how to describe this. They hit a certain point where the telescope, the mount needs to fully rotate. Maybe you can describe that a little better for me. They're getting the moon resituated. So we'll talk a little bit about what to expect when totality does hit, which we have 21 minutes until that time. I'm going to take a quick moment to answer a couple of questions because there are a few really good ones in the chat that I wanted to mention first. One person said, when can I see the eclipse if I live in Ohio? Right now. Go outside. The moon's up where you are. You can see it. In 21 minutes, you will also be seeing the total lunar eclipse happening. So go outside. You can see it right now. Get out there and start doing it.
If the moon is in your sky, you are seeing the lunar eclipse. As long as it's clear out, or even remotely clear, then as long as it's visible in the sky, you are seeing it exactly when we are. You don't have to wait for a later time, an earlier time, anything like that. The moon just has to be up, and it is up right now for you in Ohio.
Oh.
There's our view.
And look, there's our view. It's already back. They were too fast. I couldn't even, make stuff up for a long time until it got in view. They did a wonderful job. Colleen also mentioned to us maybe re-explaining some of the orientation you might see, though. Well, let me check and see. Yeah. So if you look outside in the sky right now, sorry, I had to check up in the sky myself. You might see this flipped horizontally from what you are seeing through these telescope feeds. That just comes down to the glass, the lenses that we're using in here can flip things. Good example that you might be able to think of is if you've ever looked at yourself in a spoon, you might see, well, it looks extra wonky because it's not, a perfectly shaped, it's not perfectly shaped like lenses and mirrors that we use in telescopes. But you'll see that it can be flipped horizontally or upside down sometimes. Same kind of principle going on.
And the camera that's in the telescope, we don't pay attention usually to, is it oriented, is it rotated to match what you see in the sky? So basically, if it doesn't match, just turn the phone until it matches what you see.
Exactly, yep.
So
you can always flip it around in post-processing, right?
Yeah.
Well, as you can see, checking out the live view of the partial eclipse going on right now, it is getting slimmer and slimmer by the moment. So we want to spend our last few minutes here before totality hits talking about what we can expect to see when totality does start. So to start off, we have another little short video that we did, another activity that you guys can try at home. In the video, we'll talk about some of the supplies that you'll need, but pretty standard household stuff that will explain why we're going to see that reddish color that we talked about earlier when describing the blood moon. So take it away, former self.
Have you ever wondered why total lunar eclipses are red? Well, to answer that question, we need to answer a different question first. Why are sunsets red? It all comes down to our atmosphere, the layer of gases that surrounds the Earth. When light from the sun hits these gases, the gases scatter blue light around. When the sun is higher up in the sky, its light doesn't have to pass through that much atmosphere to reach us here on the surface. This means only a little bit of blue light is scattered, leaving the sun to appear a pale yellow. More yellow than it really looks like as seen from space. But as the sun gets lower and lower in the sky, its light passes through more and more atmosphere, scattering more and more blue light. What remains after the blue has left? The magnificent shades of red and orange that you can see at sunrise and sunset. To demonstrate this concept, let's try an experiment using a few simple supplies. You'll need a flashlight, preferably one with an incandescent bulb, and a couple of glue sticks from a hot glue gun. You'll notice these glue sticks are very different lengths. The smaller one will represent the shorter journey that sunlight takes through our atmosphere during the daytime. When we shine a flashlight through the glue stick, you'll notice that the light on the other side appears as you might expect from a flashlight, mostly white with a hint of yellow. Now, let's try that same test, but using the longer glue stick. Just like the light from the sun during sunrise or sunset, the light from the flashlight now has to travel through more material. What color stands out more at the end of the glue stick in this experiment? Red. Now, you may be wondering, what does this have to do with the lunar eclipse? More than you might expect. While the moon is within the shadow of the Earth, a bit of the sun's reddish light still makes it to the moon. But this light hasn't taken a direct path. It has gone through the Earth's atmosphere. Piecing this all together gives us the exciting answer to our question. A total lunar eclipse is red because the moon is experiencing the light of every sunrise and sunset happening on Earth in that moment.
All right, welcome back, everybody. Look at that moon getting slimmer and slimmer.
Your former self did a good job on that video.
Thank you. Now, while we can predict what kinds of colors we might start to see at totality, while we have these colors that we typically see during a lunar eclipse, or that are more likely, right? Talking about that reddish color that we see, it is a little bit of a surprise, right? Total lunar eclipses can vary pretty significantly, and I think this is one of the most exciting parts of watching a total lunar eclipse. Watching this partial phase, you kind of know what to expect. You see that dark shadow moving over it, but totality is when it gets really different, and we actually have a scale that we use to represent this called the Danjon scale.
Yep.
So this represents, we use this to describe some of the different colors that we see during totality. So just like when you go outside at sunset, each sunset doesn't look exactly the same. Just like that, each total lunar eclipse will not look exactly the same. So these are two examples of total lunar eclipses taken in the same year where you can see a really distinct color difference. So they can range from this bright, almost crimson red, all the way to these like deep brownish grays, and any range of like orange and different colors in between.
Correct.
So what are some of the kinds of like conditions that can cause these colors to change?
Yeah, so what you're seeing, as if you saw the video that Hunter did, that we showed a few minutes ago, the sunlight is shining through the Earth's air at the edge of the Earth. And so you're collectively seeing the light of sunrises and sunsets happening at those specific locations right this very second. But the clearness of the air, the cloudiness, dustiness, if there's been a big volcanic eruption, a big sandstorm somewhere, you can have these atmospheric effects in this wide range of places in that ring of atmosphere around the Earth that can all affect what color you see. How much of that red light is scattered? Is it going to be a bright red eclipse? Is it going to be a dark gray eclipse? We never know what we're going to get till we see it. And so we're all kind of poking our heads around to see, is this one going to be a brighter one, a darker one? It's looking darker.
And I will say, if you haven't gone outside and looked at this lunar eclipse yourself, I have to say that it looks quite different in the camera view versus to my eye when I look in the sky.
Yep.
So in this camera view, you'll see that, we have this slim crescent, but you don't really see the rest of the part of the moon that's in that shadow right now. And that's because, cameras are really good at adjusting to a very particular lighting setting, right? And so this is really focused to see that little slim partial phase that we see right now. Our eyes are a little bit more complex. Right now I can see some dark stuff over here, but I can also see some bright things right here in front of me. And so while the video was playing, I went and looked at the partial phase as it was going, and I noticed that I could see that bright crescent part that was remaining, but I could also really start to see that red color in the shadow. So I'm thinking we're gonna get a pretty spectacular lunar eclipse tonight.
We'll see. We've got about...
Let's see, 13 minutes. 13 minutes to go. Now we had a couple of questions that came in. When is the next lunar eclipse occurring in America? Just about a year from now. It's happening in early March of next year. If I remember correctly, I think it's March 6th?
March 3rd.
March 3rd. Okay,
March 3rd.
thank you for being better at remembering dates than me.
I've got it right in front of me, right
great.
here,
That
because I
helps.
was looking up the answer to a different question. So,
So lunar eclipses, we often see them every year, every couple of years, things like that. The last total lunar eclipse that we had visible in North America was just about 2.5 years ago. So they're not super infrequent, but still always a joy to go out and look at. Now, this other question, I'm glad Michelle's here with me because this is actually a new one for me. I'm excited to learn about this. Somebody asked, when is the next set of tetrad moons? So maybe tell us when the next set is, but also describe what that means to viewers out.
I haven't yet found the answer to when the next set is. It's at least after 2034. I know that.
Okay, so a while. 10 plus years from now.
Exactly. So first to explain what a tetrad set of moons is. So 4 total lunar eclipses in a row. That's what that refers to. Now, lunar it's tetrad, tetra 4. And so the thing about lunar eclipses and solar eclipses, not everybody gets to see every single one of these solar or lunar eclipses, but the lunar eclipse that's later this year, North America, South America, we're not going to see that one, but over in Asia, they're going to be able to see that one. So a particular location, you could see 1 or 2 or 3, maybe 4 total solar eclipse or total lunar eclipses in a row. So one right after the other. And so I haven't yet found the answer. I'm gonna keep looking for our tetrad question asker.
So whoever asked that, stay in the chat. Don't go don't go too quick.
So
we'll try to find that before the end.
At least in Chicago, which I had to pick a location to look it up for, but at least in Chicago, which means most of North America, we're not gonna see 4 total lunar eclipses in a row, at least until after
at least
sometime
another decade from now.
2034. So I'll see if I can find the answer for you.
Don't hold your breath. Don't hold your breath until until the next tetrad moon.
How about later? It's going to be later.
There should be plenty more streams before then.
Exactly.
So you're welcome to come back and ask again sometime if we don't get your answer today. Now, we can guess a little bit about what totality will look like tonight. We might not know the exact color and things, but there are some things that we will know about totality. So one thing is that the Earth's shadow that it casts into space is a lot bigger than the moon is in the sky, right? And so there are different lunar eclipses where, the moon will pass deeper into that umbral shadow that we talked about earlier, that dark central portion of the Earth's shadow. And then there will be, other ones where it only goes a little bit into the very edge of that umbral shadow. So for this one, it hits about halfway between the center part and the edge. So you might notice that it may not be a uniform color tonight, that you may have some parts of it that will be a little brighter. It could be very dynamic and change throughout the time of totality, because unlike a solar eclipse, this doesn't only last a couple of minutes, or sometimes a solar eclipse is 30 seconds, right? This totality will last almost an hour tonight. So lots of time to take a look and see what's going on on this total lunar eclipse.
Yeah, sometimes the
oh yeah, look at them up in the exposure here on it, starting to see that shaded portion of the moon there.
So we had to...
Starting to see some color on what would be, you know, on the bottom right corner of it there.
Had to adjust the contrast a bit, adjust the exposure time a bit, because we're still getting that brighter part of the moon that's still a little bit outside the dark umbral shadow. So when it's fully within that umbra shadow, they can adjust the settings a little bit more. So aren't human eyes amazing that you can just go outside and look up and see that? And we have to adjust some settings on a camera to be able to do that. So I find human eyes absolutely fascinating.
I know, it blows me away what kinds of details you can get in it. So you'll see them messing with the camera settings a lot as we reach totality. So, you know, you can imagine that's because, no, it's great, Richard. You say sorry to me over there. It's very essential because the moon's gonna get a lot darker as we go, right? It really does make a big difference in the sky. And so we will see it start to change a lot as we go. And for folks that are at home taking pictures of the lunar eclipse tonight, this is good tips for you too. You know, you're gonna have to tweak the settings that you've been using throughout the night a little bit as we get closer and closer to totality, and even as totality progresses, you might need to tweak those settings a little bit.
Yeah, and also you may notice even during totality, you may still have to adjust your settings because the temperature change can affect the
right,
focus
yeah.
of
There's
your camera.
tons of different things that influences this. I love this view here with our kind of most magnified view of the lunar eclipse tonight. That little slim bit that we have left. You can see just a few details left on the moon there. I'm so sorry, I gotta go take a look for myself before we hit totality. I want to see the little teeny one.
That's fine.
Have you found, how far are you now into the future?
No, I haven't, but I did find that 2029 is going to be really interesting. We get a really nice partial solar eclipse in January of 2029, and 2 total lunar eclipses that year, one in June and one in December.
Wow. 2029, a big year.
2029 is going to be rocking.
Only a few years away. Only a few years away.
Oh my gosh, it's only 4 years away. Holy cow. Anyway, so how's it look?
It looks, I'm sure you can probably hear me even if you couldn't see me. It looks amazing right now. Just a little bit of that bright moon remaining, and most of it is getting so much darker.
Oh, wow.
For any folks that are just joining us as totality's hitting here, let us know if you have any questions in the chat for us. Somebody said, when will it turn red? Well, if you go outside and look at it with your eyes, it's already pretty significantly red in the sky. Totality begins at 1:26. But as we said earlier, in
1:26 a.m. Central Time.
Yes, thank you for clearing that up. In 6 minutes. That's a better way to put it. In 6 minutes.
There you go.
Now, as we said earlier, the shadow's a little fuzzy, right? It's not a perfectly crisp shadow. So, you know, that exact moment that it happens might vary a little bit, but it is coming up here in just a few minutes that we will have totality hitting and the blood moon appearing in the sky, right? We had talked about that term blood moon earlier. Some folks were asking about what exactly that means. So that term has come up in the last couple of decades, about the last 20 years. It's really gained popularity. It's more of a colloquialism than an official astronomical term, but it is used to describe lunar eclipses because of that red color that we do see during totality.
I don't know how good this is going to look, but we have a C-star telescope. It's sitting over here. I can control it using my phone, and the image that I'm seeing of almost total lunar eclipse is kind of amazing. And I don't know if y'all can see this. You see that red color?
Hey, yeah, you really can. That's pretty good. Yeah, not bad, not bad.
That's so cool.
So that's, I would say, like a little closer to honestly what it does look like if you go look at it with your eye. I mean, it has a little more detail.
But one thing to remember is you're gonna take pictures, you're gonna see pictures. A lot of times your pictures are gonna look more red than you're going to see with your eyes.
Good note.
Why?
Especially once totality starts, right? So right now we were saying the camera's not picking up that dark color as well because of the bright part, but especially once totality hits, yes.
Exactly, because cameras are going to be more sensitive to red light than your eyes are.
Right.
Your eyes are not very sensitive to red light. So it could very much look very different compared to what your eyes see versus what your camera sees. And also, tip, a lot of the photos you see after the fact, they've gone through Photoshop. They might have adjusted the colors a little bit.
There's quite a bit of editing that goes on,
there's
and
editing.
you know,
It's a real moon. Don't worry. And the color is real. It's just that they might need to process the image a little bit, especially if you might be stacking images together. And so it's not that anybody's trying to fake you out. They want to make a picture look really good. And
and outside of lunar eclipses as well, you know, post-processing and, you know, combining images together and adjusting colors and things is very, very important to astrophotography. It really wouldn't be possible without it, because sometimes the things that we're looking at are, you know, even outside of the traditional visible light spectrum that we're able to see with our eyes, right? Something like the James Webb Space Telescope is a great example, right? The JWST they launched just a couple of years ago and has been sending amazing pictures back to us. A lot of that is viewing things in infrared, things that we wouldn't actually be able to see with our eyes, right? So they are translating those into colors. So, you know, I never want to say that the post-processing that is done in astrophotography is lying. That's not true. It is, you know, doing editing to bring out certain details that we're trying to notice.
Yep, or in the case of a lunar eclipse, just showing you that red color that your eyes may or may not allow you to see quite as easily. And so
now some of them are exaggerating just to make it look more red. To be honest, but that's okay.
Yeah, if you're seeing a just strikingly red-looking moon, I'd start to wonder.
I would say a good comparison for what you can expect to see with like the deepest red lunar eclipse is something that you could describe as like brick red, maybe. You know, something where it's not super vibrant, bright red like a fire hydrant. You know, and I would say more comparable to like a faded rusty brick color.
Exactly.
Well, we are down to just 2 minutes before totality starts. It is 1:24 a.m. here in the Central Time Zone.
Yep.
But yes, just 2 minutes until totality. So folks at home, get outside. I know there are some people that I know that their alarms are going off right now so that they can get up and go outside and look at this, because they didn't quite want to stay up for the entirety of it, but they wanted to make sure that they caught that total lunar eclipse.
And we
watch as that shadow fades away, getting slimmer and slimmer.
Cool. That's really cool. If it is at all clear where you are, go outside. If you can see the moon, please go out and see this, even if it's cold.
Yeah, and especially right now, the moon is like has been really high up in the sky recently.
Yep.
It's, you know, almost directly overhead. So even if you're in the city, wow, that is so beautiful. Wow, they're doing a great job over there with the telescopes.
Oh, you guys are killing it. This is awesome. So they're sitting over here to our right. The telescopes are right over here. Our Sea-Star telescope is over here. Yeah.
So even if you're in the city and things and have lots of buildings in the way, you should be able to spot the moon if you know, at least go around and try a little bit, walk around to some different areas, and it'll still be nice and bright. You'll have a plenty good view of this total lunar eclipse happening tonight.
You're gonna have to wipe the smile off my face for
I know.
days.
I'm glad that we planned the stream so that we weren't live for the entirety of totality, because I'm definitely gonna go stand outside and just stare up at it for a good few minutes after this ends, and then break down all the equipment. But first, I'm gonna need to appreciate the moon first.
So if you're wondering, so 1:26. Totality is right about now.
Should be starting real soon here. Watch it get dimmer and dimmer, but as we said, it will be a gradual change as it gets deeper and deeper into that shadow. Even if you see, you know, look at your own shadow outside during the daytime, you can see that those edges aren't perfectly crisp, that they're a little bit fuzzy. But you can really see it starting to go away now. Sorry, when you see us leaning in, it's because we're trying to get closer views of the eclipse.
We've also got a ring light in front of us, and so I don't want to have to do that in order to do that.
But so just trying to take a look at all of those details, because this is really just exciting for us as it is for all of you watching from home. Well, there you go, really starting to get that color in.
They're adjusting the camera settings so you can see this, and oh man, that might be my favorite one right there. That's cool.
great question in the chat. We were just talking about this a little earlier. Do we think that Blue Ghost will send an image of the Earth from the moon during the eclipse? I can't seem to find any high quality images on the web of that, so that'd be really cool. So to the best of my knowledge, that's an image that we haven't really gotten before,
No,
right? We've
no.
never gotten a lunar eclipse from the moon, right?
I don't think so. I
And
don't
so
think so.
that
So it'll
they are
be-
planning on doing that,
Yes,
correct?
they should be taking pictures right now. I don't think they're not going to send pictures back live. They're not going to be able to do
It'll
that.
take a little time, which
They'll
makes
get the
sense.
images back.
They're the things on the moon, right? That's fair.
Right. Yep.
So while we won't get them immediately, we do expect to see some of those. And so far, everything else that has happened since they landed has been going successfully. So I don't have any reason to believe that this would not also be successful. So we are hoping to get some images back of that. And what can we expect to see from those images?
Gosh, we'll see what we
Well,
see.
yeah, I guess the answer is
That's one
something
thing.
new. We really don't know
That's
exactly.
one thing I don't know. I did look around for this information. Is what exactly is the camera going to be pointed at? Is it going to be pointed at the Earth? Which means, will you see?
Yeah, because I
like
don't know what the
like a
field
solar
of view
eclipse?
of the camera is either. It might be. I don't know how wide it is.
I don't know.
In the
Also,
sky,
is it
so.
is it pointed at the landscape? Is it pointed
Ah,
at the
right, like the
local-
shadowed landscape. So this brings up a lot of interesting conversation about, what's going on to make this lunar eclipse possible,
I'm gonna
and
go
what
look.
kinds of things. Yeah, go ahead. And what kinds of things you can expect to see in these pictures. So maybe they're looking down at the lunar surface, seeing it as it is underneath the Earth's shadow, right? If you saw the total solar eclipse last year, that had a major impact on us here on the Earth. It got very dark out. We had, a 360-degree sunset, sunrise kind of appearance all around us. Very unique experience. But if they're looking upwards in the sky and checking and looking towards the Earth, they would see something more akin to a solar eclipse, right? So in this alignment, we have the sun, the Earth in the middle, and the moon on one side. Well, during a solar eclipse, we have the sun, the moon in the middle, blocking our view of the sun, right? So this time, since the moon is on the opposite side of the sun, that means that the Earth will be blocking the view of the sun, but it'll appear a little differently than a total solar eclipse does from here on Earth, right?
Yeah.
From here on Earth, the moon and the sun are very similar sizes in the sky,
Yep.
which is really part of what makes total solar eclipses so rare, but also so remarkable, right? It gives us this big view of the corona, right? All of these things. Now, from the perspective of the moon, we're the same distance apart, but the Earth is much
Bigger.
larger than the moon is,
Yep.
right? 4 times the diameter of the moon.
So it's gonna block out that inner corona. that
It'll
you
block
would
out a
normally
lot
see.
more of the corona. So really curious to see what we can expect. But if you were here when we were talking about the color of a lunar eclipse and how we are seeing this sort of refracted light from sunrise and sunset happening all around the world in that moment, I'm really curious to see what exactly that looks like from the moon.
Yeah.
Being able to see that
Yeah,
almost
can
that
you
ring
see
of
that
red light
ring-
around it. I'm really so curious to know. I don't know too much about the capabilities of this camera, what it's going to pull off for this. I can't wait to see these pictures. So I'm
Yeah.
just as excited as our chatter that's watching here with us tonight.
Absolutely. All right, more questions, folks. We're gonna be
Yes,
on
if you
a few more
guys have
minutes.
any other
So-
questions, we will be wrapping up here soon. Only because, while we love sharing these moments with you, we also want to make sure that you're not stuck inside and that you're getting outside to watch this total lunar eclipse for yourself. It's also getting pretty late at night.
Yeah, it
I
is.
am sleepy.
So a few practical tips if you're going to go outside. If it's cold where you are, bundle up in layers. If it recently snowed, then get your feet up off the snow, off the ground. That'll keep you a little bit warmer. Make sure you put a hat on, bundle up. If you've got those hand warmer packs, put those in your pockets. If it happens to be a little warmer out where you are, it still is going to be a little chilly this time of night. It's going to be more humid, and so you're going to feel chilled more quickly because of that humidity. So still kind of bundle up in some layers if you can. It's not freezing by any stretch of the imagination.
It's so interesting in this picture now. So as we're changing these camera settings and things, look, we're starting to see a few more of these background stars that I wasn't really noticing before because the moon was so bright, right? It's kind of washing out the sky around it.
That's
We're starting to see
right.
more more stars than I was seeing before. I don't know if I really noticed those earlier when we were looking.
Yeah.
So it's fun to see some of those other details come out.
That's
Actually,
really
if
cool.
you're outside looking, you probably can see other stars around the moon much better now than you could before.
Yeah.
As the moon is getting darker and darker,
Yep.
right?
Yep. And so if you're just joining us, we're at the campus of Southern Illinois University Carbondale. We are from the Adler Planetarium in Chicago. We're joining our friends down here for a spectacular total lunar eclipse. It is amazing. It is a very dark red color. Oh my gosh. I think it's even a little darker than the last
other
two
ones that we've
you and I
seen, which
saw.
they've been really spectacular the last few years. They really have.
Yeah.
What time is peak totality? Good question. So this totality is lasting about an hour. What's the exact time that totality ends?
2:31.
2:31?
Central time.
Central time, right. So starting at 1:26, right in the middle, right around 2.
Yeah.
Right around 2 a.m.
Yep.
Another one, sorry, go ahead.
I was just going to say, notice in the view of the moon, though, that even part of it is a little bit brighter than the rest.
Right.
That's because part of the moon is a little deeper into the dark part of the Earth's shadow than the rest of it is, and so that's why you're seeing a variation in that brightness.
Somebody asked, and it's tough to answer this question only because I don't know where they're coming from. Did you guys see the shooting star? If you are currently at the exact location that we're in Carbondale, Illinois, then maybe we could have had the chance to see the shooting star, but those are really pretty localized phenomenon because of how they happen, right? So shooting stars aren't actually stars really far out in space. They are actually little bits of space rocks and dust and things, what we would call meteors, entering our atmosphere and burning up. So that was a piece of rock, maybe even as small as a grain of sand, entering the atmosphere very close to you.
Yep. So maybe 50, 60 miles up. So if it sounds like a long way, but it's really not. And so if you saw the shooting star, actually, could the person who saw the shooting star tell us where they were? So if you don't mind, or at least tell us the state, where you don't have to tell us your exact town. Don't tell us your address. Just tell us approximately where
the answer
you are.
to your question is no, we did not see the shooting star, but you really might be surprised. The more time you spend outside, and tonight you just happen to be out looking up at the sky for a couple of hours, you can really see shooting stars pretty frequently. They do happen quite a bit, and the more time you spend out there, the more of them you'll see.
Yep.
So some other questions that we have. Are animals affected by a lunar eclipse like they are in a solar eclipse? Not really so much, maybe a little bit. I mean, it is changing.
That would be a really interesting piece of research, because there may be some birds that navigate, that might be flying using the moon, the brightness of the moon. And so
in Rockford, Illinois, not too far away. Well, if anybody else in the chat is in Rockford, let us know if you also saw the shooting star tonight. Maybe you did.
That'd be cool.
It is, if it was like a not particularly bright one, then really you need to be in Rockford or the surrounding area. The really, really bright ones that are bright enough to see on the news, like the green flashes and things, maybe you can see for 100 miles range, something like that.
But for a very practical reason as to why Hunter and I did not see it, we have a tent.
And we got a tent right above us and a really bright light right in our face.
So if you see, why can't they just look up and see the moon? It's because we have a tent top over us, and so we have to peek out over and from underneath it. All right.
But with the solar eclipse, it's a much more drastic and sudden change where we're going from daytime to nighttime.
So someone else in Washington State saw a shooting star. You both saw different shooting stars.
Yeah, those ones would be different shooting stars, but tells you just how common they really can be. And if you go and spend time out in the night sky, it doesn't take a meteor shower to see these things happening.
Yep.
They are happening all of the time, right? Where the Earth is constantly being bombarded with little teeny rocks. That is lovely.
3 to 5 an hour. But now that the moon is not bright in the sky, you might have a better chance of seeing some of those.
Some other questions. What is that bright corner that we see? So since totality has just begun, the moon is not that deep into the dark part of Earth's shadow, and so, you know, shadows aren't perfectly crisp, right? You've got a big sun shining light from all different directions at the Earth. They're a little fuzzy on the edges, so you'll actually notice this throughout totality. We'll see which areas are brighter and darker change a little bit. As it gets closer to returning to the partial phase, you'll see the opposite side start to get brighter later. So lots of different things. Some other questions we have. What direction is the moon in on the eastern coast?
All right, so yep.
Due south and high in the sky.
So
it'll be really almost straight above.
Yep, so here in the central time zone, it is almost very high in the sky. Toward the eastern coast, it's going to be a little bit more toward the west. So you'll have to go out and look a little bit more toward the west in order to find it. So those of you west of us, it's a little bit more toward the east. So there you go.
I'm just gonna read this comment because it's funny. Lots of people are saying thank you and saying you both should go look at it also.
Okay.
Do not fear. We've got another 50 minutes of totality. I'll get lots of chances to look tonight. I promise. I won't miss this opportunity.
Thanks, guys. Thanks for giving me permission to go look. I love that.
Another question, is the lunar eclipse improving or decreasing from now on? The moon is still getting further into the dark part of the shadow, so it will continue to, I guess, improve, if you want to say it like that, until about 2 o'clock, and then it will begin, totality doesn't end until about 2:30 Central Time, so, 20 minutes from now, an hour from now.
Yep.
Let's see.
So it may even get a little darker than it is now, and it's already, this is pretty dark, so yeah.
One other question was, how often do lunar eclipses occur?
On average, it's once or twice a year, but they're not all total. Some of them are partial, meaning the moon only passes partway into the dark part of the Earth's shadow, and Hunter's gonna go look at it. And some of them are not even partial. The moon only passes through the lighter outer penumbral shadow, and so those types of lunar eclipses, we kind of don't tell anyone. Well, we don't really hype them up to go outside.
Right, because they're really tough to see. It's nothing like seeing this dark red, dim moon in the sky.
So
this is so special.
When the moon was maybe, I don't know, about 25 minutes prior to the start of the partial eclipse, you still had a really tough time seeing it when it was still in that lighter penumbral shadow. And so it just depends on which part of the Earth's shadow the moon encounters, and that determines what kind of a lunar eclipse it is. And you can get 1, 2 or so of those a year, and then not everyone is going to see all of them in a year. So you might, but you might not. And so yeah, because you have to remember, the moon's only visible on half of the Earth at a time, right? Just like the sun's only visible on half of the Earth at the time. Yep.
So one person asked, is it gonna get any redder than it is right now? Could a little bit. It's really hard for us to know. Like we said earlier, total lunar eclipses, the totality phase in particular, is very hard to predict exactly what it will look like. We can have really accurate predictions about the timing and all of these things, but the color of the lunar eclipse is so dependent on the Earth's atmosphere that it makes it harder to predict. It's almost like the stuff out in space is easy to predict. The stuff that happens here on Earth is a little bit more difficult to predict. So there's a chance that it could get a little darker like that.
I would ask our viewers, what color are you seeing right now? If a few of you could post, what are you seeing? How would you describe that color? I'm gonna go take a quick look and see.
Yeah, get outside, see how it looks. See how it looks for you. We'd love to hear. This is actually some research that is currently being done during lunar eclipses, where people all over the sort of area where it's visible are documenting what the lunar eclipse looks like from their location. They're documenting what the conditions are in their location, like the weather and things like that. And this will help us be able to better predict these things in the future. Right now, it's still really tough, but we're always refining and learning new things in these processes.
Yep,
right?
I would say I would call that color maybe it's not brick red.
Yeah, maybe like a what's burnt sienna look like? Is that reddish or is that kind of brown?
Kind of reddish brown.
It's pretty orange to this time, I feel like. It's It's hard to describe colors.
Is it that Crayola color, brown, red, brown?
Yeah, something like that, right?
So more brown than red, I'd say.
We've got lots of people trying to describe what color they're seeing in the chat as well. I'm seeing lots of light orange, kind of light red.
I really want someone to go find that Pantone color that it might be.
And so you know,
go through the paint chips. And
we have a scale that we use to describe the color that we see on these lunar eclipses. We talked about it earlier in the show. It's called the Danjon scale. You can, if you look up the Danjon scale online, you'll see some of those different representative kind of images of what that looks like. And they can vary really significantly. So that's how, you know, observers of lunar eclipses often describe them to each other. It's not necessarily a very scientific scale because it's really about what you're seeing with your eyes. It measures the brightness of it, the color of it, right? And so that kind of can give you an idea of how we can compare with each other. It's a 1 to 5 scale there.
Someone put brick color. You know,
I like that one.
I think that's even a little better than saying brick red. I think brick.
Right, the color of a brick itself, right? And like kind of like an old brick.
Yeah.
You know, one that's like weathered away a little bit. It's like kind of dusty, right? So it's a little more brownish gray.
You know, here in Carbondale, some of the streets still have some of the brick.
They do have some that are pretty worn down from people driving on them and stuff.
It's kind of that. And I'm pointing in the direction as to where they are in the town. They're that way. So yeah, and you can't see it, but if you come down here, you might see it. So anyway.
Well, as we are getting further into totality, we will be wrapping up here on the stream soon. So if you do have any final questions for us tonight, you can post those in the chat. While we wait for any of those final questions that you have, wanted to give another special shout out to not only the folks that we have here in person helping us behind the scene, our producers, Dylan and Brody, Richard, and the rest of the telescope operators that we've had here tonight, Colleen and Gaza in the chat, Farmer's Almanac and all the folks joining us from farmersalmanac.com. Tons of people that we have. Many thanks to give tonight. If you've enjoyed watching this show, we don't only go live for lunar eclipses, we go live for all kinds of fun astronomy stuff. So subscribe to the Adler Planetarium's YouTube channel below. Outside of the streams, there's tons of other astronomy content that goes up. Some things that are educational, some things like Wow Signal that are a little more fun and, you know, more comedy focused. So lots of great astronomy stuff to check out here, and we would love to have you come back and join us for a future stream.
And please visit us in person at the Adler Planetarium in Chicago. You can go to adlerplanetarium.org and look for tickets and come and see us sometime. If you're an Illinois resident, we have Illinois residents get free general admission every Wednesday night, every single Wednesday night. Yep. So you can come on down.
There's another extra fun thing that happens on Wednesday night too.
Yeah.
The Dome Observatory out behind the Adler Planetarium will also be open. Our open time it varies throughout the year. We open once it gets dark, but we stay open until 10, and that is also totally free for anyone to come and check out. We've got a 24-inch telescope that you can look through. If you've been to any of our other shows, you've probably seen that telescope. Usually that's our backdrop behind us, and so we would love to have you come and look through that telescope. Of course, that is weather permitting.
Yep.
But if it's a beautiful clear night like this, you can come and observe with us. Let us know that you were at the lunar eclipse stream. You will see, well, either you, me, or Dylan will be there, so you'll see one of us out there that night. So come and say hi. Let us know that you watched the lunar eclipse with us.
And many, many thanks. We cannot say thank you enough to Southern Illinois University Carbondale for hosting us. They let us use their electricity, their internet,
yes,
their furniture, you name it.
That's true. We're sitting on their chairs. We've got their telescope views that we're looking at tonight. And they are a huge, huge supporter of the programming we do.
And many thanks to all of you for taking time out to not only see something in the sky, but we did it together. And we really appreciate that. You could have done anything else, including sleep. And you decided
that is true. That
you
is
decided
true.
to look up at the sky, and we will always be grateful for you for being able to do that with us.
Yep.
So thank you very much.
Colleen will be posting a feedback survey in the chat where you can let us know how you enjoyed the show, what kind of topics you might be interested in seeing in the future, things that you would like to see us change. We really appreciate hearing back from you.
Yep.
And before we leave, one last question in the chat: how often do lunar eclipses occur?
So once or twice a year on average, but the next time we get to do this again here for a total lunar eclipse being visible in our part of the world
Right,
here.
in North America here.
March 3rd, 2026.
Yep, almost exactly a year from now.
Yep,
so.
we'll see you there on
Yep.
Sky Observers Hangout.
We will definitely be here on Sky Observers Hangout, so hopefully we can see you then as well. Other than that, thanks so much for coming tonight, and have a great rest of your evening. Get out there and see the rest of this total lunar eclipse, which is exactly what I'm about to go do.
Thank you, everyone. We're going to keep the feed on the telescope, the view on the telescope feed for a little while longer, so you can enjoy it with us. But go outside, take a look at the moon. Thanks a lot, everyone. Good night.